On September 26, 2023, NASA opened a space capsule carrying the largest ever sample of the asteroid Bennu hazard. Scientists at NASA's Johnson Space Center in Houston discovered a surprising layer of black dust and debris on the container's avionics bay. The 100-gram sample exceeded the expected amount of dust from Bennu, despite the fact that it had been securely sealed throughout the flight. The origin of this unexpected black dust remains a mystery. What scientists expect to discover during a thorough analysis of this historic asteroid sample is of great significance. When the OSIRIS-REx mission launched on September 8, 2016, it had three primary goals. First, it aimed to collect pristine samples from the asteroid's surface, providing vital material for scientists to study and understand primitive asteroid composition. Second, the mission sought to characterize the asteroid by mapping its surface, determining its composition, and assessing its potential as a resource for future space exploration. Finally, the third key objective was to address Earth's potential impact hazard. As previously mentioned, Bennu is a potentially hazardous asteroid. On September 2135, Bennu is scheduled for a close flyby of Earth. Our planet's gravity will influence Bennu's trajectory, making it challenging to calculate its future path. This is due to the fact that, in addition to gravity, non-gravitational forces like the Yarkovsky effect can influence asteroid movement. When sunlight hits a rotating asteroid, the day side warms up as it rotates, while the night side cools down and radiates heat. This process generates a small force on the asteroid, which gradually alters its course, on the Yarkovsky effect, which gradually alters its course. Modeling the Yarkovsky effect is a complex task, and it can significantly affect the asteroid's final position. Due to uncertainty about how the Yarkovsky effect will influence Bennu's orbit, our understanding of Bennu's location as it approaches Earth in 2135 is limited. As a result, scientists need to consider various potential paths, depending on the strength of the Yarkovsky effect's influence on Bennu. Some of these paths align with specific areas in space, called gravitational keyholes. If Bennu were to pass through one of these keyholes, Earth's gravity would deflect its trajectory in a way that could lead to a potential impact in the late 22nd century. The probability of this scenario is relatively low, but scientists aim to gather as much information as possible to assess the risks involved. On December 3, 2018, the journey to Bennu began, spanning a 2-year and 4-month voyage. After covering about 1.4 billion miles, OSIRIS-REx reached its destination and entered orbit around the asteroid. This marked the start of a series of surveys and mapping activities aimed at selecting the ideal site for sample collection. The most exciting phase of the OSIRIS-REx mission occurred on October 20, 2020. During this phase, the spacecraft employed its touch-and-go sample acquisition mechanism, which briefly made contact with the asteroid's surface to collect a sample. This is a robotic arm attached to the spacecraft's main body that retrieved the sample from Bennu and placed it into the Earth return vehicle. Given Bennu's small size, with just a half-kilometer diameter, the arm had to carry out this delicate operation in almost zero gravity. OSIRIS-REx had just one opportunity with no room for error. When the spacecraft made contact with Bennu at a location known as Nightingale, it used a burst of nitrogen gas to stir and lift surface material into the sample collection chamber. The minimum required sample size was 60 grams, but during the brief 9-second contact with Bennu, OSIRIS-REx collected an impressive 300 grams, which was 5 times more than NASA had expected. However, an issue arose as the collected material started escaping due to a jammed flap caused by larger rocks. To prevent further loss, NASA decided to forgo the planned sample measurement and sealed it for return. On May 10, 2021, OSIRIS-REx departed from Bennu, marking the start of its journey back to Earth after nearly 2.5 years. On September 24, 2023, the spacecraft reached the vicinity of Earth and released the capsule, carrying the asteroid sample. The capsule entered Earth's atmosphere at a speed of 12 kilometers per second and employed a parachute to decelerate its descent. Safely, the capsule touched down at the Utah test and training range, where NASA personnel recovered it a couple of days later. Subsequently, scientists at NASA's Johnson Space Center opened the lid on the sample return canister from the OSIRIS-REx mission, and what they saw both surprised and thrilled them. Upon opening the sample canister from the OSIRIS-REx mission, scientists were initially met with a layer of dark powder and sand-sized particles that likely originated from Bennu. This coating wasn't confined to the interior of the canister, but extended to its exterior, including the avionics deck where the electronics were housed. The dust managed to escape from the canister through small openings between the lid and the body. The natural question that arises is, how did this occur? NASA suggests that when OSIRIS-REx briefly touched down on Bennu, it generated a shockwave that rippled across the asteroid's surface, leading to the ejection of certain materials into space. Some of this material trailed behind OSIRIS-REx as it departed from Bennu and adhered to the spacecraft's outer surfaces. Additionally, a portion of it entered the sample canister through the open flap, mingling with the material gathered by TAGSIM. The combined mass of the sample, including the dust and debris, measures approximately 400 grams, exceeding the required means for their scientific goals. Furthermore, it's reported that the sample remains in excellent condition due to minimal exposure to high temperatures or contamination throughout the return journey. However, the presence of dust and debris on the avionics deck poses a unique challenge. It necessitates careful handling and cleaning by the scientists who employ specialized tools and techniques. They aim to remove the dust and debris from the deck without causing any harm to the electronics or losing any of the material. Additionally, they must meticulously document and catalog each fragment of dust and debris, since they're integral components of the sample inventory. The reason space agencies invest billions of dollars in missions to visit small asteroids, even those that are only half a mile wide, is because these celestial bodies serve as invaluable time capsules. Asteroids formed in the early solar system, during the period when the planets were still in the process of forming. They are composed of the same raw materials as the planets, but have not undergone the geological processes, such as plate tectonics, that have altered the Earth's surface over time. As a result, asteroids have the potential to preserve a pristine record of the early solar system, a record that is often lost on Earth due to these geological changes. For instance, scientists have discovered a variety of organic molecules on asteroids, which are considered the fundamental building blocks of life. The presence of these organic molecules on asteroids suggests that the necessary ingredients for life existed in the early solar system. The discovery of organic molecules on asteroids is an especially exciting find, emphasizing the scientific value of these missions. Yuga is classified as a carbonaceous asteroid, indicating its richness in organic material. In 2020, the Japanese spacecraft Hayabusa successfully returned samples from Yuga to Earth. Subsequent analysis of these samples revealed a diverse array of organic molecules, including amino acids. Amino acids are the fundamental components of proteins, which are crucial for life. This discovery raises the intriguing possibility that the essential ingredients for life may have been delivered to Earth through asteroids in its early history. The next phase of the OSIRIS-REx mission, now named OSIRIS-APEX, will shift its focus to the study of asteroid Apophis. Apophis is a near-Earth asteroid with a diameter of approximately 1,100 feet. It is set to make a close approach to Earth in 2029 and carries an estimated 1 in 150,000 chance of impacting Earth in 2068. OSIRIS-APEX is scheduled to reach Apophis in April 2029, shortly after Apophis' close encounter with Earth. Over a span of 18 months, the spacecraft OSIRIS-APEX will closely examine Apophis from orbit. Utilizing its array of instruments, it will capture images and create detailed maps of the asteroid, enabling the study of its composition, size, and shape. The OSIRIS-APEX mission plays a pivotal role in enhancing our knowledge of near-Earth objects and the potential threats they pose to our planet. The data collected during this mission will contribute to our efforts to better safeguard Earth from potential asteroid impacts. On a different note, the James Webb Space Telescope recently unveiled the secrets of a star named Randall, which holds the distinction of being the most distant single star ever observed in the universe. This star exists at the very edge of time. If you missed the exciting findings revealed by the Webb telescope, it's worth catching up on this remarkable discovery.